Okay. Oh, make sure I can hear myself. I haven't plugged in, that's why. Okie dokie. Welcome to the stream. Let's see if we have anyone actually watching us right now. Oh. Live, we have excellent stream. We have one viewer. That's good. Let's see how we doing on Twitch. Okay, Twitch is being a little slow. Yeah, Twitch is being slow. Okay, welcome to the stream. Hi, I'm gonna say 1, 2, 3. Welcome. We're going to go over the brand new MicroBlaze RISC-V processor. We're gonna do a quick speed run of it. It's fairly the same process as doing the normal MicroBlaze. There are a few feature differences, but they're not a big deal. Ugh. Okay. Oh. Cool. Welcome. So we're gonna do a speed run for the brand new release today MicroBlaze for Vivado 2024.1. It was fun. I downloaded like 100 gigs. Took like 4 hours to get this up and running. So we are going to open the new tools. We're going to target the Digilent Arty board it has an RTX 35T. We're going to do a very basic MicroBlaze RISC-V, and then we're going to add a UART for Hello World. Afterwards, we can look at the options. I kind of looked through. There's not really much to talk about. I am curious about Axie Stream, so if you want to stay on longer, we can see how we can connect the Axie Stream towards the system. At the moment, there is not any documentation posted for the MicroBlaze RISC-V on the website. But let me see if we open up DocNav. This is the correct DocNav. And see if DocNav has anything for the MicroBlaze. Okay, we are up to date. MicroBlaze V. Nope. Okay, there's no documentation. We'll look for the documentation afterwards. It should pop up. Okay, so let's go ahead and open Vivado 2024.1 and begin. Ugh. Maybe we should include the program start time as part of the speed run. Because it can take like a good minute for Vivado. I mean, sometimes I'm referencing licenses that aren't there, so it's a little bit. I'm doing a little bit more stuff to my Vivado. My Vivado build than normal people are. Ugh. Come on. I see you there. It's on the other window. It has the thing. Okay, while we wait for Vivado, anyone have any comments, questions about the MicroBlaze? It's gonna pop up in a second. Here we go. Oh, okay. Okay, we're going to start the timer. Let's go. We're gonna call this one RD1. Okay, we're gonna do a normal project. Boards, I already downloaded it. I don't really think that's a problem. Finish. And boom. Cool. That was easy enough. Okay, we're going to do the MicroBlaze 5. We're going to do a run block automation. We're going to bump this up to 32. I want that space. We can't do UART, which I'm sad about. We'll do a new clocking wizard, that's fine. We do. Come on. Not that hard. Come on. Okay, we're good. So if we grab this clock, weird. Fix it this way. The board interfaces seem to have some issues. Like this wasn't properly updated to support the interface. Let's get rid of that. Reset. Cheat. We're at the lock signal to the external run right there, and then we're going to drop the UART line or USB UART, AXI light. Yep, double click this, parameters, set it up to the best baud rate. Okay, cool. We're gonna validate it, we're gonna save it, we're gonna create a wrapper, and then we'll close this portion. Create HDL wrapper. Then we'll, as soon as it shows, okay, cool. Next step, we're gonna do generate block diagram. And then we're going to export the XSA file. Oh no, this is not special request. This is public. This is off the new Vivado version. This is not special access for the MicroBlaze V. This is a public release as of today. So we're going to go file, we're going to go export hardware. We're going to do pre-synthesis. We're going to call this a top. Okay. We have generated the XSA. So now we're going to generate bitstream. Yes. While the bitstream is generating, we're going to go ahead and open Vitus 2024.1 and do this in parallel. How long Vitus takes to run. Okay, we can watch this as it builds. Let's see if we can get under 10 minutes. I think we should be able to get under 10 minutes. Okay, here we go. Vitus IDE. Okay, so we're gonna open a new workshop. I hate this type of interface, but whatever. We're gonna go to here, new folder, workspace 00, select folder. Now we're going to create a platform component. Next, we're going to browse for our XSA file that does not have a bitstream. We are going to do the RISC-V on MicroBlaze V. It loads. Okay, cool. Next, yeah, we're gonna finish. Let this build. It's going to take a bit of time. Like this should be faster. Well, no, it did finish the UART light. Finishing a bunch. Like, but where's the information? Like information. Okay, so the platform. We're gonna go ahead and build the platform while we do this. Figure out my error term. Okay. We built it. Go to the board support package. We can see that it's using the AXI UART light. So now we're going to go to examples. We're going to say hello world. We're going to create example. Back over so we can see it better. Next, we're going to select the platform. Next, hit this. Standalone RISC-V. Hit next. Finish. Okay, so are these supposed to have better lock? Okay, so I guess these are done. Copied cached. You have cached information somewhere? Weird. Interesting. Okay, now we can go ahead and build this. Okay, so we actually finished the Vitus build pretty fast. But here, there's a bitstream file. We're going to want to load it as soon as this finishes. So implementation, there's going to be a bitstream here. So we will paste it down. Okay, come on. You got 2 minutes. This is probably slowing it down. Okay. We should be done soon. Finish nest. Let's clean up. Okay, we're done here. Let's go to implementation. Started this initializing. Here we go. So I guess we'll just watch this. This is much more boring than the other one, but we're doing much faster so far. I feel like the build should have been much faster. We're doing vendor only, so it's a vendor tool assisted speedrun if it has to be that way. I don't have an aimbot. There's faster ways to do this. I guess we could do like GUI lists if we went straight up for tickle commands. That would be really probably be a lot faster. But it should go fairly fast at these stages. Since we're doing a relatively simple design, there's not much utilization. All right, look at that. They were already down to routing. Placement was really fast. Placement information to look at. Perfectly fine on timing. We could probably bump this up to 125 megahertz, no problem. That might be an interesting thing to see how fast this processor could go. Why does it keep going back up? It should stay down. Okay, finish routing. Okay, we're writing bitstream. We're almost there. Okay. Okay, cool. We're done. So we bring this window back up. And now we're going to grab a top wrappered out bit. So that's now ready to go. We have our tera term window here, and we can just run. And we can look at the source in a second. Doing system reset. Task complete. Hello world. Oh. Okay, cool. Didn't update my time as well. Okay, so we did this in about 12 minutes. I feel like I need to fudge the numbers a little bit to go. Let's see. I mean, it was probably like, what, 30 seconds? Let's go fudge the numbers a little bit. Oh, no. Okay. I wonder if I should change out those numbers a little bit. We could run it again. See how it goes. But that was fairly quick. I mean, we probably could just, I would say, here, match the numbers. I forgot the update. Okay. Okay. A little fudging. So there we go. Fairly easy to look at. That was quicker. I do like the examples better. We could go ahead and run a dry stone on it as well. And just see what we get. Do not support dry stone. No, it says it supports it. Let's go ahead and do it. Hit next, I guess. Doesn't like you clicking. Okay, so say 12, 13, 22. change it. Like 4. Okay. Yeah, I'm gonna look that up though. Okay. Let's go ahead and build the dry stone. Dry stone build failed? Why did we fail? Annoying. Oh, we don't have a timer. Okay, we can add a timer. Let's do it. Let's do that. Let's go ahead and update this to add a timer. Okay, so back here, they want a timer. So let's go ahead and add a timer. On connection automation. Now, if we have a timer, we probably want an interrupt controller. Then let's add a concat. Interrupt there, interrupt there. Boom. Okay. One last thing I want to add is in the settings. This settings look very similar to the normal MicroBlaze settings. We have our RISC-V extensions here, but we're going to go to this. I want one stream link. Okay. Yeah. And I want to wrap this around. I'll add a little FIFO. Stream FIFO. It's this one. Want. Boop. Boop. Block reset. Okay. And you're probably fine. Okay. Validate. Okay. Save this. Generate block design. Actually, let's just go ahead. Yeah, let's generate block design, export it, and then generate the bit stream again. It's bundled with the new Vivado. So yeah, so MicroBlaze 5 is part of Vivado 2024.1. Okay, that running. I guess that's where it's going to add these new systems. Let's go ahead and switch in workspace. Go ahead and open a second one here. Okay. Okay, just normal settings. Okay. I don't think I can. Yeah, we'll just call it there, I guess. Okay, that's good. Let's export it. We're gonna call this this two. Then we're gonna generate the bit stream while we get the dry stone running. Okay, let's go ahead, create a platform component. Next, browse. Any other questions? Any questions that I've missed? Fairly quick. Oh, I was curious about the documentation. Documentation product guide. Oh, it's referencing the wrong one. That should have been installed properly. Weird. Yeah, doesn't look like it was installed properly. Hmm. So it should be this one. Oh, do we have... Okay, let's see. MicroBlaze. Where do they not have MicroBlaze? Where is... Okay, MicroBlaze. See. Did they include it in the new one? No, that's an old one. I don't see it here. Yeah, I don't see where the documentation for this MicroBlaze is. I'll have to go hunt it down sometime. Not on here. I don't have it listed anywhere. Okay. You have any information? Nope. Nothing useful. They're just gonna go. Okay, here we go. Oh, this just goes here. 0.1. I don't see anything for MicroBlaze V or 5 or whatever. Yeah, I'll have to chase that down. See if I can find it on a different system. Okay. Bitstream is complete. Cool. So let's head back to here. Go ahead and add the dry stone to the platform. Build it and then reference that. You're not doing anything different, are you? Yeah, I don't see the documentation for it. It's so weird. Okay. I guess let me go ahead, open Vitus on that one. Vivado. And okay, so back here, we're gonna build this. I want to creating the platform first. Whoa, whoa, whoa. What happened? Why did the dry stone fail? No, that's not enough information. Failed. Okay, where's the output window? You're not providing me enough information for why my build failed. Those aren't failures. Those are just warnings. Unless, did you have walls somewhere in here? No. Why'd you fail? I guess I could try classic and try to build you in classic. Okay, cool. We're gonna build you in classic. Annoying. Okay. Okay, we're looking for UG 1629. UG 1629. Okay, let's see if Google can find UG 1629. 1629. UG 1629. MicroBlaze copy. Probably just go straight to the link actually. Okay, so we're gonna try user guide. Guys, we found it! We found it! Okay, cool. Found the unlisted documentation. Okay. What's this fault tolerance? I'm curious what fault tolerance you're adding. CC. Okay, we're just throwing ECC. We want to do that. Okay, what about the streaming interfaces? Oh, this is literally updated today. Wait. Okay. Oh, we were going to classic. Where was classic? Okay, so let's open up classic. I want to get the dry stone to work. And also the stream interfaces. They talk about the stream here, stream interfaces. Yeah, but what's that's just the boring stream protocol. Yeah, I want to know the write operations using one of the put instructions or the get instructions. The get the custom commands without prefix expect okay, let me go back here. It's the library. We're using Git. Okay. It's not that one. Is it this one then that I have a more sophisticated? Yeah. Okay, so C put FSL, and this is coming out of MicroBlaze interface.h. Okay, we can go hunt that down. Okay, classic. Here we go. So we're gonna go through the classic approach because apparently this one hopefully will build the example more appropriately. Now we want to go to RD1, that one. Next, we'll say try. Yeah. Give me dry stone. Cool. And yeah, build. Oh, okay. Better errors. You overflowed by that many bytes? Okay. I can deal with this. We're gonna go to build settings. Optimizations. Optimization for size. Apply and close. How much do you overflow now? That barely helped. You actually rebuild it. It looks like you did. What's the linker script look like? Linker script. What we got? How much space we gave it? Remind me later. Address editor. 32. It's asking for a good more. How much more can we give it? Okay, we could give it a probably 4x. Gives us 32. So we can probably bump that up to 128. Open all. Dump that up to 128. Okay, so we can't do dry stone yet. Let's just run this in the background again. But I do want to look at the hardware. No, the MicroBlaze, BSP, lib source. Okay, library. We have the MicroBlaze interfaces. Right here. MicroBlaze interface.h. Okay. So are we assuming these will work as well? Okay, let's go. Let's apply a new application. Standalone MicroBlaze. We're gonna say MB Dream. Sure. Next. We'll do Hello World. How are we doing over here? We're just increasing those systems. Shouldn't take too long. Okay. So ahead and build that system. Take too long. And we're gonna go to Hello World C, and we're gonna say include MB interface H. And what we want to do? We want to do like a what FSB, right? We want to put and a get. And what's the thing here? ID and value. So value and ID. So we're gonna do D 0. And then we got here. How does that work? We call get. Okay, so we want to give it a register, then get a 0. Do you build? Okay, no such directory. Is it not there? Am I not spelling it correctly? Definitely interface. Okay. Are you not including it in your nope, it still doesn't like it. But it's there. There's a special one for the stream interfaces. What did the instruction guide said? The instruction guide said you want to use I guess we'll just, you know, grab this then and say hello. Will this build? Okay, where is stringify coming from? Oh, we have a RISC-V interface. Okay, cool. We want to use this file. Where's this file located? bspin include? Oh, that is such a weird thing. Okay, we want to do RISC-V interface. So we want to do RISC-V interface, then build. Okay, you're happy there. We want to do xile, you know, printf, whatever, percent or 0x, percent 08x, background. A0. Okay, and then rebuild. You know, like xile, oh, printf. And okay, now if we try to run this on hardware, the run configurations, do you have exported bit file that we're loading with it? Target setup. Oh, there's no bitstream file. Okay, so this is gonna fail. Yeah, it's not gonna fail with the stream. I guess we could load in this one real quick. Yeah, it's almost done. Oh yeah. Linux will not run on run for this system at all. You could probably do your own build route. I mean, there's plenty of RISC-V build route examples that we could probably reference. A lot of them are using this HAL system. So if we go here, close that for now. If we go bring up this window, right? We go targets. A lot of these people are using this heart system for like their little OS. So I assume that we can get a lot of the Linux or build root or Yocto Linux. You could probably write your own Linux for this system relatively easy. Xilinx would probably, you know, provide, you know, the background for a lot of the different drivers for their subsystems and whatnot. But it should be a lot easier to get custom Linux working on the RISC-V processor rather than a full system. Okay, that's built. Remind me later. Fix the dry stone in a second. There's a way to update hardware specification. Okay, but first, let's um okay. Yeah, let's do that. So we are going to export this again, and then we're going to update. But hardware, we're going to include the bitstream this time. And we're going to call it top v3, finish. Go here, right click this. We're going to update hardware specification. Ask for v3, generate it. And then we are going to select top v2 down here and say build. And there should be here. Okay, we have the bit file there. Okay, so now if we go run configurations, we should be able to find it. There we go. apply, run, reload it, and we should see if we get the dead beef. Oh, sorry. What's in the screen? Load the FPGA, load the software. Did it rerun? I don't think it reran. Let it clear buffer. That is again. Show that. Yeah, it looks like it's getting stuck. I guess this is a good time to go try out the debug version of what's happening. Okay, we are line here. I guess we'll step over. Enable caches and UART. UART. Turn on this. Okay. Deregister. Did it not like that call? Weird. Okay, now it's just going. Oh well. Okay. We can't get the stream interface working. That's kind of expected. We should be able to build a dry stone now. I just rebuilt this. Oh, I gotta rebuild the linker script. Linker script. Or no, we gotta right click. Go here, right click, generate linker script. Yeah, we got 128. Generate. Yeah. Okay, rebuild. Okay. We're gonna go ahead and run this one on hardware. And you terminate. Okay, let me fix this real quick. Terminal. Receive auto. Okay. Rerun. We should be able to read it better. Okay, so we have a DMIPS of 0.9, 0.9. How did that? Let's see how that compares. Where? Let me go hunt down. Okay. Was it? Where? Which one was it? There we go. Okay, how does this compare with the previous MicroBlaze? So the previous MicroBlaze got a 0.63. And the performance version, the MicroBlaze got 1.58. Okay, let's compare this to Taiga. We got the Taiga core. Did I put that README here? Really, did I not calculate that? Taiga. I had better readings on this. Oh well. Okay, so it looks like pretty good performance that we could probably improve upon. So yeah, let's report that. Okay. Thank you for watching. Leave a like, whatever. Follow, subscribe, anything you want to, I guess, support, spread awareness of soft processor speedrunning. I'll post a tweet on these results, and I think we can call it good for the stream. We broke it in a few ways. I don't know how to get this working as expected. We'll put, no, that was, should be get. That still broke. I don't know what's up. Okay. Thanks, everyone. Good night. Oh, you want a Pedalix demo? Yeah, we can do some. We'll do some PCI stuff. We'll do TLP, bare metal, and Pedalix PCI stuff later this week. Okay. I'll work on getting that one set up.